We are looking today at direct and inverse variation. Our goal today is to be able to create models based on direct and inverse variation systems. So let's have a little look and talk about what is direct and inverse variation. So some systems, some two variables can relate to each other directly. One example of this one might be if you imagine a variable which describes the amount of tomatoes you're buying at the supermarket, and then the other variable being the cost. So if I just draw a little pair of axes on this one, and we've got weight in kilograms, and then we've got the cost in kilograms, it's easy for us to understand that this is going to be a direct variation of a linear type, whereby the more the tomatoes weigh, the more the cost will increase. The more the tomatoes weigh, the more the cost will increase. This is an example of direct variation. Direct variation. Direct variation uses the terminology. We could say that if the weight is W and the cost is C, then we would say that that C is proportional to W. C is proportional to W. This means that the cost will vary directly with the weight. To give you an example of a system which is inverse variable, an inverse variable, let's say we have the number of people. I'll call this one P. And then the time taken to complete a task, call this one T. So the time taken to complete a task would relate to the number of people doing the task inversely. So imagine your task is to clear all of the dirt from the beach on a strip of sand, large strip of sand. If you have one person going along picking up all of the dirt, it's going to take them maybe 3 days to cover it all. If you've got 3 people, it might only take them 1 day. If you've got 10 people, the time's going to be going down and down. This is an example of inverse variation. It's going to have a graph that looks like this. In this particular case, we would say that the time taken to complete the task is going to be inversely proportional to the number of people. And these are our two systems. So this is an example of inverse variation. These are our two systems. We're going to have a go with a couple of examples of these. Okay. So here's our first example. The distance meters that a rock falls varies directly with the square of the time taken. So let's pick apart the question. What is our x variable here? What is our x variable? Our x variable is going to be time in seconds. Our x variable is going to be time in seconds. Our y variable is going to be distance in meters. So these are our two variables. Our x variable is the time taken. It says that the distance varies directly with the square of the time. So it's the distance that varies. It's the distance that varies directly with the square of the time. So the time has to be squared. Notice this terminology here. It says it varies directly with the square. It's very clear in the question. The distance d varies directly with the square of the time taken. And then we have to try and determine what the proportional system is. So in order that, I just go back onto this one. If we're doing direct variation, if I buy 1 kilo of tomatoes, does it cost 1 dirham? No. Why not? There's some other factor, isn't there, in that? There's some other factor. If I buy 1 kilo of tomatoes and I buy 1 kilo of chicken, it's not going to cost the same amount. Yeah. So when we take our proportionality statements, we turn them into equations by adding a constant of proportionality, K. So in the case of direct, it would look like this. In the case of inverse, it would look like this. Now that K, in the example of the tomatoes and the chicken, it's the cost per kilo. It's the per kilo price. So we would need to find this constant of proportionality. So what we've got here is a constant of proportionality. That's one of the hardest parts to see. That is one of the hardest parts for you to actually figure out if you're not told directly in the question. You have to use your own common sense and your own interpretation of the world that as you understand it. So like in this example, you can see how the more I'm going to buy, the more it's going to cost. Or the more fuel I put in my car, the more it's going to cost. The more it weighs, the more it costs. That's direct. Whereas you have to understand sometimes that in some systems that the more people helping with a task, the less time it's going to take. You have to make that interpretation yourself. A lot of the questions on the exams will tell you varies directly, varies inversely. They often tell you, and they'll often say varies inversely with the square. Like for instance, with radiology and intensity. Intensity of radiation varies inversely with the square of the distance from the emitting electrode, and that type of thing. So in this case, it tells us that it varies directly, and it tells us it varies directly with the square. So we need to insert our constant of proportionality. So we've got D is equal to K times T squared. So now in the question, it's going to give us two values. It gives us this number here, 6 meters, and it gives us this one here, 2 seconds. Now looking at the 6, is that D or T? How do we know that's D? So read carefully. You're basically reading the question carefully. D is about distance in meters. 6 is in meters. This means that this is a D. T is in seconds. This is in seconds. So this is a T. So we can substitute these two values now for D and T. So if D is 6, that has to be proportional to 2 squared. We can end solve this if you want. We don't think we need to end solve. We're going to have 4 times K is equal to 6. K is equal to 6 over 4. K is equal to 3 over 2. So lastly, we can create our model. And we know now that D is equal to 3 over 2 times T squared. This is our model. So just reread the question, make sure I've done that first part. If a rock falls, write an equation for D in terms of T. That's my answer, that's my model. Now, B. The distance the rock has fallen, find the distance the rock has fallen after 5 seconds. So what we've got here in this one is we've got 5 seconds. Is this a D or a T? This is a T. This is a T, time in seconds. So we can use the formula we made in the previous part in order to insert our new value, which is 5. We're going to get 3 over 2 times 25. 3 times 25 is 75 over 2. I think that's about 37.5. You can use a calculator here if you wish. Meters. Reread the question. Find the distance. I found a distance, 37 meters. That seems like I've done the right thing. Any questions on this one?
Once you make the equation, can you put it in the graph and then...
Yeah. You could, exactly. So you could put this into the calculator. You're going to get a graph for this one. This is a direct variation, but it's varying with the square. So you're going to get a graph that looks like this. Sorry, let me just take this question first. And you'll see that it's going to go through 5,37.5. Sorry, the question at the front, was it? So varying by the square, that's there given here in the question. So it says it varies directly with the square of the time taken. And this comes from the physics of the situation. Objects in freefall motion are a quadratic model, so they vary with the square. So for instance, if you imagine when you drop something, it starts falling slowly to begin with, and then it will fall faster and faster until it reaches terminal velocity. And it'll just keep increasing its speed. And if you look at the graph there, you can see how the distance to begin with will increase slowly, and then it will increase faster and faster as time progresses. It will give you it in the wording of the question. It will give you it in the wording of the question for this. You don't have to understand the physics in it. But it's useful for interpretation to see and understand these things. Okay? So let me just finish this little diagram off here. This was time. In this case, time was x in seconds, and this one here was distance in meters. From the wording of the question. So it says that the distance varies with the time. So distance varies with the time. You read the sentence like this. Distance varies with the square of the time. It says in the question, distance varies with the square of the time. And then the independent variable is the one on the left. All right. Here's another example. It's our last example. The number of hours, n. So there's one of our variables. Let's highlight that one. Hours, n. To build a wall varies inversely. So the hours varies. So the hours is the y value. It varies inversely with the number of people x. So this is our second variable. Can have a go at writing down a proportionality statement using one of these models here. Use one of these models here. Have a go at writing a proportionality statement like one of these two. Which one is it? Which one is it? All right, so let's have a look. You should write n varies inversely with the number of people. N varies inversely with the number of people. So this means that n is equal to k over x. Now, let's find the numbers. We've got 3 people are available. The wall takes 2 hours to build. Okay, so the 3, is that an X or an N? Is the 3 people an X value or an N value? X. So we've got X equals 3. The 2 hours to build, is that an N or an X? That's an N. So this is N equals 2. So we can insert those into our equation and find that 2 is equal to K over 3. What's the value of K? K is our constant of proportionality. Like in the example at the beginning about weight and cost of tomatoes, 1 tomato doesn't cost 1 dirham. There's some constant of proportionality in the system. And like for all of these systems, we'll have a constant of proportionality that creates that sort of balance to make it work. And it comes out of using this first coordinate pair. So what we've got here is a coordinate pair, 3, 2. The graph is going to go through this coordinate. All right, so what is the value of K? 6. So what is our model? N equals 2 times 3. What is our model? N equals 6 over K. This is our model. All right, so B. Let's have a look at B. Yes. Oh, sorry, I've written K instead of X. Okay, so for question B, it takes 3 hours. So we've got a number here, 3 hours. Is this an N or a K? I'm sorry, an N or an X? So this is an N. So we've got N equals 3. So in this case, we've got the coordinate X, N, and we have to find X. So let's put that into our model. Our model is N equals 6 over X and N equals 3. So 3 is equal to 6 over X. Use your calculator to solve this now. What is the value of X? And solve if you wish. So have a go at solving this equation here. Right. So if we algebraically, you can rearrange it as well if you want. We get 2. So reread the question before you exit. Given it takes 3 hours to build the wall, how many people worked on the wall? So we would say 2 people would take 3 hours. Well, the answer there is 2 people. Okay, that is it for today. Have a go now at the questions in exercise 9J. 9K. There's also some IXLs assigned today, which you can find on the Google Classroom.